Start them.
Okay, I think, yeah, go ahead. Trying to find. Yes.
Can you see your screen okay?
Yep.
All right. Ready?
Do the camera before we all good to go.
Everything good? All right. Everything is. Go ahead.
Welcome to our NASA Hunch design presentation. We have our programmer and project lead, John Lee, our station designer and artist, Justin Butler, and myself, Ethan Howard, as the environmental designer and artist, our teacher, Melissa Goodall, and we're from the Miami Valley Career Technology Center.
Excellent.
Our project that we chose to do was a simulated gravity VR AR station. The object was to create a VR experience of being in an artificial gravity space station, also modeling nearly the International Space Station. Our solution to this was to use the Unreal Engine 4 because it came with a built-in VR integration. It had decent physics and it was pretty much built for like using the 3D environments. It was free and open source and relatively simple to use with good user interface for us, and we were familiar with the language, which is C++.
All right.
I like free.
So for the physics, we decided to go for a full physics simulation where the station itself is spinning. The station's angular velocity and any collisions with physics objects or the character will transfer that velocity. And we also decided to add a subtle drag effect to help any objects sort of floating along to start moving. Now, this was a more challenging solution than some of our other ideas, but it was also possibly more realistic with more opportunities to simulate real life phenomenon. And we have a video to demonstrate the sort of physics here. Now, I wanted to go over some terminology first. We decided to use a cylindrical coordinate system to refer to the walls and the surfaces on the station. The reason why we did this is because it was more convenient to do, and it was just simpler to work with to have a method of naming walls in a more intuitive sense for the station. And so this way we didn't have to confuse left, right, up, and down. So the cylindrical coordinate system is defined as rho, phi, and z. Rho is radius. It is the distance from the center of the station. Phi is angle along the station. There's a picture here on the right that we pulled from Wikipedia. And z is up and down. It's the same as the Cartesian plane. So first we have our core programming challenges. So the first issue that we wanted to bring up was that of the VR headset's positional offset. And this was an issue we weren't quite able to solve before the presentation. So the positional offset is tracked as a Cartesian translation, but we need it as a cylindrical one. And what I mean by this is that if I move my head up in the in virtual reality, normally that would be a positive z translation, but we need it to be a negative rho translation. Now, Unreal's implementation of VR was hard-coded, so we weren't able to overwrite this very easily. There are some possible solutions. One that we came up with was to add the inverse offset. So if the camera is moving this way, we move it back the opposite way. So that way we can start fresh and add our own implementation on top of that. But this was a hacky solution and it wasn't exactly elegant. But the alternative is to rewrite the engine code, which was far too daunting a task for us to try and accomplish in our limited time. So the first solution is likely the one we're going to be moving forward with. The second issue was regarding movements. And again, it's very similar. The built-in systems are based on the Cartesian plane, but we needed it in a cylindrical reference frame. So we came up with two different movement regimes. One we call jetpack and one we call row-lock. So the first one is very simple. The character is just a free-floating physics object, and we apply a force forward if the character wants to move forward. And this is a regime that activates when the gravity is near zero. And it works pretty okay. The Unreal's physics engine is very good at handling this, but the problem was that it didn't handle friction between moving surfaces very well. So when you were hit the ground, when the gravity was turned on, you would start sliding around, and it was very nauseating in VR to do that. And it was just a bit inconvenient. So we came up, oh, here's a demonstration on the bottom right. You can kind of see what we're talking about. It's there's got some inertia to it. The movement doesn't stop when we want it to stop. So the second, we came up with the roll lock regime. So the position is stored as a cylindrical vector. So we stop simulating the character as a physics object, and we just set the position to what we need it to be. And this activates when the gravity has reached a certain threshold and the character is touching the ground. And this removes the sliding issue. And I'm gonna show the demo here. You can see the movement is a lot more crisp. It stops when we stop. And this removes the sort of nauseating sliding effects when the gravity is turned on. And the last challenge that we had was to provide a system to which we wanted to provide a system for the user to have an intuitive sense of the weight of objects on the station. So we have a system called physics holding, in which we can hold objects like this 1 kilogram cube here. We can and also this 5 kilogram cube, which you can see that it takes longer to accelerate. And also, this is the way this works is we just have a set force on the object that we're picking up, so the set force is the same between objects. So heavier objects will have the same force, but they'll take longer to accelerate. Lighter objects will be snappier, and if it's in higher gravity, it'll also take longer to accelerate. Okay. Because its weight is higher.
All right. We ran into a few interesting things in designing the environment, and some of them were basically just based on the fact that it is a circle. So when we tried to create a flat surface, such as a table, to hold anything that could possibly slide or roll around, we discovered that it would just slide off the ends, because in order for something to be like flat and hold anything, it has to be perpendicular to the pulling force. But since it changes depending on your location on the station, it would have a different amount of pull on either side of the flat surfaces. The solution to this is to create a curved flat surface to hold anything, keep it from sliding off the edge. There's a few exemptions to this, and it would be our barbell platform for safety, anything that's confined that could hold anything from sliding off, the computer tabletop, which wouldn't be usable, and the toilet for comfort, as well as anything that would be too small to be really affected by the fact that it is radial. So we did implement some ladders, and we would just put them up like any normal ladder would do, but something we ran into was the Coriolis effect, which would pull the user either off the sides of the ladder or like into or away from the ladder based on the rotating station. So we decided to put the ladders along the positive or negative phi axis, because it'd be similar to either pull the user off or pull them into it for comfort and safety rather than point it off to the side, which we ran into some other issues with that as well, which was the treadmill for safety concerns, because if you are running on a treadmill, there is a chance of you being in free space if you're using it as a normal person would. And that could either pull you off of the sides or pull you into or away from the treadmill as well. So we decided to put it in line with the rotation of the station so that it would pull you slightly backwards off of the treadmill, because it'd be better than throwing you into the front of it or pulling you off to the side, because if you just fell off the back, there's a better chance of you catching yourself and not getting injured. Here is an example of the Coriolis effect on the station by picking up an object and then releasing it. You can see it moves backwards slightly.
Do it again, would you?
I'll just
Very good. Good job.
Thank you. Our acceleration display displays the amount of G's that any user would be feeling on the station. It's large, so you can easily read it, and it's local, so that means that it changes depending on the location from the floor of the station, which is the outer ring that has the most gravity being applied to it, and it lessens as you get closer to the center of the station.
So for the station design, here we have an exterior image of the model with dimensions on the left side. I'll give you a second to look at that. On the next slide, we have the interior layout of the station here in a diagram with the key on the left and right side, color coordinated. Each line represents the different interior rooms. For the windows, we opted into putting 2 windows on the positive and negative z-axis. This allowed for more viewing angles for the crew members and decreased the distance that crew members would have to travel from the windows to sleeping quarters.
Excellent.
Here is a display of how disorientating the windows can be if you're looking out of them while the station is moving or rotating. For the bathrooms, we decided to put them facing each other because bathrooms usually don't require that much space. And as for the layout, we put them next to the galley for better plumbing, as these are the only rooms that would require plumbing. For bedrooms, we went through a few different designs, but ultimately we landed on having 3 rooms connected on one side of the wall in 2 quadrants each. This seemed to be the most optimal for space, which we'll get into later. For room separation, we use curtains as they are significantly more flexible than traditional doors, which is good for transitioning gravity. Now we're at lessons.
Okay, so we came across a few lessons that we didn't want to like put into individual slides here, and also want to summarize things. So first of all, the flat things need to have a curvatures thing, and we also noticed that when we started accelerating the station, objects have inertia, obviously, so they get left behind sometimes. And the heavier they are, the worse the problem. And so when you accelerate the station, what typically happens is that, especially for sphere-like objects, they just tend to roll backwards. So they need to be tied down initially. And also objects are somewhat counterintuitively harder to throw with the rotation of the station, because when you throw them with the rotation of the station, their velocity is increasing, but that also means that the gravitational force, the artificial centrifugal force, is also increasing. So they drop like a rock when you throw them with a rotation. If you throw them against the rotation, they actually start to float almost, because the gravity is near zero. And also acceleration changes really quickly as you go up, as you decrease the radius. And also that means that the weights that we have get lighter as you lift them.
So for the crew comfort ladders, we found that they need to be placed with or against the rotation to avoid that sliding effect. For the beds in the sleeping quarters, we made those hammocks, similar to why we decided to have curved surfaces. They adapt to the curvature of the station. We also found that handles would be great for to be around the station for the crew members when transitioning gravity levels. And we also found that a 15-meter radius or diameter, sorry, is quite small for 6 astronauts for an extended period of time. Improvements.
What would you guys suggest for a diameter, do you think?
I think it would be depending on the exact design of the station. If it's something flexible, like we had an idea earlier, or not, we didn't have an idea, but part of the suggestions and the requirements was like a inflatable station. You could probably make that like up to like say 20 meters, and that would not only decrease, or that not only would increase the amount of room, but it would also decrease that effect of raising elevation, changing gravity problem that we had. But
and that's those are great answers. I really like your comment there. I mean, part of my choice for going with 15 meters was just that that's the size that I thought that we could accommodate for our launch vehicles right now. But your comment, I think, is a very, because you've already done some of the designing and kind of construction, I think that that's a much better answer for us to be looking at. So keep going. You're doing a very good job.
Thank you. Okay, so we had some improvements that we needed to make because our project is not quite finished. First of all, we want to make the VR experience less nauseating. We didn't show any footage from that simply because we have problems with the positional offsets, and it's right now it's still very nauseating to view. And also, we wanted to implement a equivalent physics holding systems for the motion controllers that we have. So this way you could physically pick up the objects and sort of experience it even more intuitively than what we have built right now. And also for movements, we wanted to eliminate the jetpack movement because it is simple and it's very easy for us to implement, but it's not exactly realistic. I think something more interesting would be to build off of the physics holding idea that we had and to take some inspiration from the International Space Station. So for movement, you would be pulling things instead of just moving forward through space.
So for the station itself, we feel it could have had maybe more models, better textures, just for a better feel of realism and immersion. We will be trying to do that, but for time constraints, we went for simpler approach. But with all of that being said, that leads us to any questions, comments, or concerns.
Wow. Okay. I'm very impressed. I think that you guys have done a terrific job, first of all.
Thank you.
So Gene had mentioned that you had noticed this where you have a flat table and round objects rolling off of it. And I thought, wow, that is such an awesome statement. So I hadn't even seen it, but I just thought that is terrific. I think that is a really great observation that I don't think most people would have thought of. And so that's exactly what we're trying to look for, are these things that, we hadn't thought of that. I also like your comment about the ladders. I thought that's very good. I've always thought of them as coming down the wall, but then after you mentioned that, so part of when you watch the movies where they have these rotating spacecraft, you'll see the astronauts come sliding down the ladders, and your comment about them getting pushed one way or the other, I think is exactly right. And that would, by placing it so that they're oriented towards the rotation, I think was very smart. That's a great comment. One thought I have is that it may be helpful for orientation to have some arrows on the floor or on the walls or something that tells what direction the space station is rotating, and that might help it. It may help your being able to understand, why is it when I throw it this way it goes, I have one problem, and then I throw it the other direction, I get a different problem. And that may help the people who are learning how to use this software to position themselves in that space better. Just thoughts. If you guys have a better way of doing something like that, I think that would be just fine as well. Actually, I have a question for you. For example, okay, so you've placed the sinks and the toilets in the rotating section, okay? And you also mentioned how there are times when you're going to turn off the rotation and be able to float around, right? Which implies that our toilets, they may need to be they may need to operate either in 1G, but they also may need to operate in 0G, which gives the question of, if I have tanks of water or if I have a space toilet, is it more advantageous to have it in the 0G or the nearly 0G section in the central core, or is it better to have it in the rotating section, the 1G section?
We hadn't really thought about this, but I would say because the crew quarters are mostly in the rotating section, and all of the crew activities mostly down there, it would be more convenient to have it down there because
I agree with that.
Yeah, if the crew suddenly have an urge, I don't think they would want to climb up a 7-meter ladder to go to the restroom.
Agreed.
Yeah, that's a good point. I don't think we really looked into zero-G toilets, did we?
Yeah, so with what you said, I think for the implementation of the toilets, it would be easier to put it in the center, separate from the rotating section. But if you can make a zero-G toilet, which astronauts have, I think putting it in the rotating section and treating it as a zero-G toilet, even while it's rotating, and maybe adding different functionality to it that would accommodate for the rotation and having gravity, I think that would be better. And
Okay.
it may not be the easiest option, but
No, there's no wrong answer there. Okay. Just so you know, my background is I'm a space toilet specialist before I came to the Hunch. Okay. And so I agree with your comment about it being it's much more convenient for it to be in the 1G section next to where the people are going to be sleeping. That's exactly right. The harder question that eventually we need to be able to answer is, what's the right engineering answer, right? And the second gentleman, your comment is exactly on as well. So I think you guys are all thinking in the right direction, and these are things that we'll have to have conversations about in the future. The fact that you guys have already got a position to be able to have good reasoning for it, I think speaks really well of what the three of you have done together. I think it's an excellent job. I'm talking too much. Nancy and Jean, Debashri, did you guys have things to say?
Yeah, my main comment was, I'm very impressed with what the students put together. We all had provided some comments and feedbacks with putting the presentation, and I, like I said, I saw they implemented it. The idea of taking smaller videos, and I liked how you embedded it in the presentation, so you can you explain a concept, or this is what I've done, and then the video comes and demonstrates it. I mean, for all the areas, the windows, bathrooms, the separation, all of the areas that you were trying, you had issues with, and then also the little cupola where you showed the viewing window. No, I think you guys did a great job. Nicely done. Jean, Debashri, you guys have any additional comments?
Well, I echo everything you just said. It looks great and definitely way more than I could do on this type of project. So great job. I didn't have any extra questions.
You guys have already heard my comments before, but I want to make sure Glenn hears some of the things that I said. The fact that you guys even considered changing up the coordinate system and everything in there. I talked to the people at Epic. I have a family member at Epic that creates that runs Unreal, and I told them what you guys had done, and they were amazed. These are the people that created the software. They're saying it's not supposed to be able to do that. We didn't want to, we didn't want that in there. So the fact that you guys considered that is amazing to people. So I really want you guys to understand just that you guys knocked this out of the park. As far as I'm concerned, I'm not Glenn, okay, but from a teacher's point of view and all the work that went into all the stuff you did, discovering all the little discoveries you made, the ladder, the flat surfaces, this is outstanding work. And I really wanted to make sure that Glenn and Flo and Nancy and everybody feels that from a teacher's point of view, I know what can happen in a classroom. And with the limitations you guys had in this, you did well.
Thank you.
So another question. Oh, Flo, did you have some comments?
Yeah, I totally agree with Jean. This is an amazing accomplishment. And I did have a question for you. In your opinion, now after you worked on this rotating station, in your opinion, would it be more livable than what we have as a microgravity station?
Yeah.
What do you guys think?
I don't know. I was looking at that a little bit, and I think if the station is designed to only be comfortable in 1G, then no. For what we have now, being in 0G, it's designed for 0G. I think if you can transition between 0G and 1G without having to, or without it only being for, say, docking or maintenance or anything, more for recreational or just comfort at all, or just fun, then I think it would be a lot better than just 0G. Yes.
Oh, interesting comment. How about the other two? What do you think?
I completely agree. Having the ability to change the amount of force would be a lot easier, especially for like he said, with transitioning, especially if it's like moving around. If they had like another astronaut docking onto it for some reason from like the International Space Station, for him to move from 0G to another 0G environment, be able to transition there, it would probably be a lot easier for him as well, just for comfort.
Yeah, that I don't think NASA would want to risk doing like a interstellar style docking for every single time you need to do something like maintenance or a crew transfer. And also we noticed there's a few things that are really disorientating in 1G, like the windows that you saw.
Yeah.
Just looking out them is like you're just spinning, so you almost have to isolate them from the outside to make sure that they don't see that spinning, or else it's very disorientating.
It would definitely
What's
take
your
some-
rotation? Oh, sorry. Go ahead.
I was just saying it would definitely take some getting used to, especially with the curvature of the station. We aren't used to things like that. So
Yeah.
Yeah.
Well,
Did-
thank you
did
for
you guys-
those answers. Go,
No,
Jean.
excellent.
Sorry.
Excellent thoughts. Have you guys watched any? I suspect that you guys have watched a couple of movies that were kind of simulating some of these things. What did you notice about those? About how they depicted it in the movies?
What movies have you guys watched? I've watched Interstellar.
I can't recall the names. I'm bad with names,
That's
but
okay.
from what I have seen, I can say it was definitely unrealistic. It was kind of like they were just living on Earth. There were no problems that seemed to occur. So yeah, it was kind of just not really realistic. I wasn't really paying attention to it.
Do you guys have any other observations?
Well, not that I know of.
Well, here's another comment for all three of you. That I initially, when we were working on developing this into a project for the students, I was thinking of it specifically as NASA, right? But then after I've had a little bit of time to watch how students are doing it and to think about it a little bit more, I'm thinking that there would be a lot of value for example, I think you guys could now be kind of like consultants for making a video game or making a movie. And so part of what I'm thinking is, so Gene was just talking about how he's already talked to some people at Unreal Engine. Oh, Epic.
Epic,
Okay.
yeah.
And I think you guys might want to kind of advertise what you've done a little bit.
And that's the thing I was thinking. And I was trying to figure out the best way to do that. But the fact that this was brought to Epic, and if you guys are okay, I would say to G, hey, why not set up a meeting with Unreal Engine folks, show them what you've done, and that's one of the things we encourage you using something and see what they think.
Well, consider this. And I'm not real good at at zombie shoot 'em games or alien shoot 'em up games or whatever, but consider that if I was to shoot forward in the space station or backward in the space station or to the sides, I would have to be aiming differently. Does that make sense?
Yeah.
Because of what you guys have already seen. And so that might be an interesting component to a new kind of video game. Now, remember, this is also an inflated thing, so you probably don't want to be shooting off a lot of guns
Yeah.
inside of an inflatable module, unless you've got really good aim. But anyways, but also, you know, the idea of talking to, so for example, I got to be calling Ron Howard and saying, hey, what's your next movie? You know, because I got a couple of teams that have developed some really cool software that you might enjoy. Anyways, those are just some of my comments there. I'm very excited about what you guys have been working on. I think this is terrific. So
May I make a comment real quick?
oh, please do.
Oh, yeah, Melissa.
Please, another thing to keep in mind outside the video game aspect of it is sometimes there's value in having simulations that people can learn, especially if we're talking, you mentioned the nauseating effect of zero-G. And I know you guys have tons of things, but you know, maybe a simulation of some kind of training value would be useful as well.
And that was my first goal. And it's not so much for the astronauts as much as it's for the engineers who are designing. And so part of what I hope to see is that if I'm going to have tanks of water, I need to know, do I put them in the 0G section and they pump towards the 1G section, or do I put them in the 1G section and then we distribute the water to other section in the space station by going through the 0G section? Okay, there are fluid dynamic problems, but then there's also these other problems where I have food and different equipment that are stored in the 0G section, and then I'm going to move it out to the 1G section. And as I do that, I'm going to be changing the rotation rate because of conservation of momentum. And so there are all kinds of problems that we're going to have to think about when we start having these rotating modules, if it is really what we want. And before we start doing, before we build it, software like yours can help us answer some of those questions, right? So imagine if I take a refrigerator size rack that weighs 1 ton, and I shift it from the 0G section and I put it into the 1G section. Now I have, I'm going to slow down my rotation. Yes, and I've changed my center of mass.
Because you've moved that massive object from one area to another. Yep.
And it's also going to be lopsided.
Yeah.
That's right. And so as we transfer things in and out of that segment, we're going to change some of those rotations. We're going to, it'll change your simulated gravity to either more or less, depending on which way I'm moving it. These are all things that as engineers, we need to think about. Now, as an astronaut, I would be wanting to, let's see, let me say this right. When I fly up to the space station, for the first couple of days, I am trying to do things carefully so I don't throw up all over the place, okay? And I have to orient myself. When I come home, for the first several days, I'm trying to limit my motion so I don't throw up all over the place, right? So if I am going back and forth from a simulated 1G to a 0G, I'm curious, am I going to have to be always watching myself to prevent myself from throwing up all over the place? And so these are, all of those kind of concerns are things that we have to think about when we start putting people into these rotating spacecraft. And your software is exactly the direction that we need to go to first before we start assembling and spending $1 billion on a rotating spacecraft. Okay.
Yeah,
so
Glenn, I just wanted to throw out there with what you just said there, just put in for you guys that are constructing this thing, remember the strength of materials. If you have more mass on the outside, your space station is going to have different materials it's made out of, which again can be put into your software. There's that kind of breakability and things like that eventually will be added to your level of software. So you guys even though you guys have really performed wonderfully, it's just the foundation of where this software is going.
Yeah, and I think Gene, you brought it up. The software and seeing what you've done has generated more questions, and these are good questions because it's brought up things we hadn't thought of. But by seeing what you've done, it's like, oh, that's a great idea. Well, and then and that's one of the things engineers want to do is ask the questions so we can model it before, like Glenn says, we build it and then, you know, spend all that money. So that this is one of those neat, like I said, simulations project that generates lots of questions. And like I said, those are good questions. Those are the type of things we want to have to, you know, understand this area. So again, kudos to everyone.
So did you guys like this?
Yeah.
Working?
Sorry, I think you cut off there. The audio cut off.
I was gonna say, did you guys enjoy working on this?
I definitely did. Yeah.
You can say
it was kind of stressful, but yeah, we had a lot of fun.
We did learn a lot of things too. So
if you didn't get aggravated with it, it wasn't good enough.
So I want to know what your plans are for next year in college.
You guys know what college you're going to? I'm going to Ohio State for next year. What are you guys?
I'll be going to UD.
I'm just finishing my associates at Sinclair and then deciding from there what I want to do.
Okay. Oh, great.
Awesome.
So
I'm also planning on forming like a game development group after this, like you suggested. So that's probably
one thing I'm going to recommend to you guys, because I've done this with my hardware students, definitely when you guys are writing like letter recommendations and applying, let them know you've worked on a simulation for, you know, the space station for NASA, because that will definitely put you in a different category than everyone else. So make sure you highlight this, you know, moving forward. So, but yeah, I like the idea of, like you guys saying, starting a group for this. Nice.
One of the universities I talked to, they have a virtual reality club that they've developed. They've got about, you know, at different times they have something like about 15 or 20 people in it. And I suspect that there will be a day when it becomes a major. So I don't know if that's something that interests you guys or not, but you might look out for that kind of thing wherever you go. And part of the reason of that is just that there's a growing awareness for virtual reality programs for training for all kinds of things, including like nuclear power plants and just in terms of safety and things like that. So anyways, these are some really cool things.
Yeah. Well, even think about airplanes and aircrafts. They have virtual reality they do with a lot of the pilots, you know, so they can put different scenarios and see how the plane behaves, you know, before they get them just to practice. So yeah, the virtual reality practicing things is definitely a big, important field.
And so is the rotating laboratory, because you can look it up, just Google Brandeis University rotating facility, and they have a rotating facility. Some of the students working on this project actually spoke to the professor there. And if you're really interested in that, that's another avenue maybe for graduate work.
I suspect that university is going to start picking up some students, just because this is exactly the kind of direction that they can, or it's something that would branch off of the research that they've already done. You know, do you remember the name of I need to talk to those people, because I want them on our, I think I want them to come in on the final design review and see if they'd be interested in listening in on our projects.
Yeah, it's Brandeis University. I have the name of the professor, and it's in Massachusetts. It's right outside of Boston.
Okay, I'll give them a call here in a little bit. All right.
Nice work.
Any other thoughts or comments?
Great job.
I did want to say, you mentioned having arrows to indicate the direction that the station was spinning.
Oh, yeah.
Yeah.
I wanted to note that we did actually implement those. I'm not sure.
Oh, did you?
Yes. I'm not sure if we took any pictures of it, but there's 4 of them placed right below the connectors on the wall. Yeah, he's looking for pictures right now. I'm not sure we.
It's okay.
We can show the game engine. We can just pop that up. I think.
Yeah,
Oh,
you
yeah,
got a
that'd be
second to do
great.
that?
Yeah.
That'd be great.
I don't know if it's sharing.
So something I was looking at your brochure, that might not be bad if you wanted to, add stuff to it, is add the features that you included as part of it.
Yeah, that would be good because your brochure I noticed does have I guess what you call lots of
Oh, you're
white
right.
space.
No, okay.
there they are.
Actually, on your brochure, it is
Yes.
on the wall
Yeah.
there.
Yeah.
Very good comment. I'm glad you said that.
Yeah, and I was gonna say with your brochure, you can actually put if you want a few more pictures because it shows the 3. So feel free because you have room at the bottom if you want to add, some more pictures. Well, that's perfect.
Yeah.
Nice.
No, I think that, yeah. Yeah, if you guys wanted to add a little bit more in there, I think that'd be terrific on your brochure. The way I'm going to be using these brochures is that when I announce the semifinalists and the finalists, I'm going to be posting up the brochures just because it tells way more than what I could with any photo. So,
Yeah, so
these are kind of your calling card a little bit.
our problem with the brochure is that obviously I don't think we can put any videos on them because you're going to be printing them out.
No.
Yeah.
So,
I won't be printing them, but
Yeah.
we won't be able
But
to
you can
put
put
video on it.
yeah, that's why you
still
could just put
this stuff.
images. The images are fine. That tells a lot, the simulations.
It does.
Or a caption under each one of what it is you're trying to highlight in that photo. So like the first picture you have is that arrow showing the direction of the ISS. Like that would be good.
Yeah,
to just
and also it's showing the variable gravity, and just like
Right.
a quick, less than a sentence, just a few words, just highlighting it. Yep.
I think it also shows that you've got curved tables, doesn't it?
I think one of the pictures should.
There's a ball sitting in the middle of one of the tables, and it looks
that's
curved to me.
Yeah.
Yeah.
That's true.
Yeah, we actually have both the flat and the curved one, so we can sort of.
Oh,
Nice.
that's awesome! I am so glad that is very smart. Yeah. Okay.
Well, that is curved, and the other was that's another one that'd be cool
That'd
to
be-
put. Yeah, and if you put this picture, what you demonstrate, saying, program also shows. I made a note of it. How it takes longer to accelerate heavier objects in the 1G or something like that, because that's kind of a neat feature that yours has.
Yeah. There's some really excellent features you guys got there. Okay. And I'm talking to, which one's John?
I'm John.
Who's John? John and Justin, who's excellent, and Ethan. All right. Okay. Excellent job. I'm very impressed with the work that you've done. I don't want to take up your whole day, but I think that you've done a terrific job, and I look forward to seeing what else you guys do with this. All right.
Thank you.
Thank you.
Nice work, everyone.
Yeah.
Thanks, Melissa.
Great job.
Thank you. Thank you, Melissa. This is terrific. Is it just the one from Miami? Is that correct?
Yep,
Yes.
I think, just the one.
And you can stop recording and afterwards it will download it for you.
All right. I'm going to get going then. Thank you so much, everybody.
All right.
That was
Okay,
really
thank you.
Thank you. That was amazing.
Thank you.
Was incredible.